here. My name is Jerry Hargrove. I'm an AWS Solutions Architect on the Rackspace Fanatical Support for AWS team. And what we're going to talk about today are 5 of the most commonly asked questions that we hear when we're working with AWS customers. So let's go ahead and jump right into it. I want to remind everybody we'll be taking some questions. If you have questions while I'm talking, go ahead and post them up. We'll have a little bit of time in between each of the questions I'm answering and then maybe some time at the end. So let's go ahead and get started. So the first, probably the most commonly asked question I hear when I'm talking with AWS customers, it probably happens on a daily basis when we're working on architectures, is how do you choose the right EC2 instance type? So you have a particular application or a workload, you're going to run it on AWS. How do you make sure that you have the optimal EC2 instance type, both from a performance and perhaps an economical standpoint? Well, my answer to that is usually that depends. And let me tell you why. So when I think about AWS, I think about AWS as a set of sort of foundational building blocks that we use to build our architectures, to build our systems out. And those building blocks come in various shapes and sizes, sort of like Legos. And you can put those blocks together in different forms and end up with the same or similar things. So 2 different paths taken by 2 different solutions architects will come to differing but correct solutions. Similar to Legos, you can build a wall with Legos using different sized bricks, different colored bricks, you end up at the same place. So that's kind of why I say it depends. When we're talking about choosing the correct EC2 instance type on AWS, we have to think about questions like, what are your performance requirements? How performant does your workload need to be? What are your scaling requirements? You know, what level of scaling does your application actually require? Do you need to scale horizontally or vertically? Do you have any budgetary constraints that you're looking at? So do you have an unlimited budget that you can use to decide which type of EC2 instance you want, or are you limited? Are you on a shoestring budget? And then timing as well. When do you actually have to decide on what type of EC2 instance you want to use? Do you need to know tomorrow to put a system in production, or is it something that can happen a month from now? All of these questions will help you decide what type of EC2 instance you want to choose. Ultimately, though, you want to also understand how you measure success. How do you know that you've made the right choice and chosen the right EC2 instance? I can tell you sometimes when I'm working with customers, it sort of feels like this, like I'm actually just taking a dart and throwing it at a dartboard and choosing whatever EC2 instance the dart happens to land on. Some days it actually feels like I put a blindfold on and done that. On a good day, it sort of feels like magic or art, like we've chosen the right EC2 instance, everything is working great. Sometimes you might simply choose the cheapest EC2 instance or the first one you find on a list, or perhaps you try just mapping your existing infrastructure requirements over to AWS. So for example, you're running on an actual physical piece of hardware that's got 2 cores and 8 gigs of memory. You choose the EC2 instance that looks like that. That will get you part of the way there. It's a journey that you're going on, and that's really where solutions architects at Rackspace can help out a lot. Ultimately, though, I would really like to see something like this, a formula that lets me choose an EC2 instance based on my particular set of requirements, whether it be performance requirements, budgetary requirements, scaling requirements. This would actually be great. I'm not sure that there's a formula that will do that for us, but we can get very close to that. And so let's talk a little bit about how we do that. How do you look at the myriad of EC2 instance types and choices provided by AWS and choose one that's appropriate for your workload? Well, step 1 is knowing your workload. So, are you running performance-sensitive applications? How much CPU do you actually need? Are you running an application that is doing video transcoding, number crunching, HPC type of app? Are you running an application that is very CPU sensitive, so that if you choose an EC2 instance type that has too little CPU available, too few cores, then your performance is going to suffer, response times will suffer, or your customers will notice. If you choose an EC2 instance type that has too much CPU power, then you're leaving cores to sit idle. Another question you want to ask about your workload is, how large is your working set? So how much memory do you actually need? If you choose an EC2 instance that has too little memory, then swapping will occur, and again, performance will suffer on your instance. If you choose an EC2 instance that has too much memory, then again, it's simply wasted and sitting there unused. Another question to ask about your workload is, how do you need to scale? So how does your workload typically scale? Does it need to scale quickly? Are you running an e-commerce app or a web tier that needs to scale up and down based on customer demand, and that happens very quickly? Are there periodic changes in demand that dictate how you'll scale? You have scheduled increases, or days like Black Friday, for example, when you know you're going to have a large increase in demand. All of those things will help you narrow down the field of EC2 instances that you can choose from. And thinking about it as a dartboard again, we're starting to narrow down and cut portions of that dartboard out that we're targeting. Another thing that we can do to help narrow down that target or reduce the size of that dartboard is really then taking that information we know about our workload and filtering the EC2 instances by the category of instance. So for example, AWS provides a category of EC2 instances that are considered general purpose, that have a good balance of CPU and memory available to them. If our requirements or our workload allows that, then we can focus in on that. Or we can look at EC2 instance types that are compute intensive or memory intensive, or provide storage optimized features, or also provide GPUs. So all of those will allow us to filter down our EC2 instance selections. Now we're narrowing the field, reducing the size of that dartboard that we're choosing from. Once we've done that, we can then start looking at the capacity, or the capability of the EC2 instance. So looking at particular features of our application. Does our application require a lot of network I/O? Then we may be required to choose an EC2 instance that provides high levels of network bandwidth. Do we do a lot of reading and writing to EBS volumes? Then choosing an EC2 instance type that is EBS optimized would be the right choice for us. Are we doing lots of work on local drives, so ephemeral drives that are attached to EC2 instance types? All of these things will help us narrow down our choices and choose the correct EC2 instance type. This really ends up being our sort of science, our formula for choosing an EC2 instance type. Once we've done that and we've filtered it down, then we can start narrowing in on an actual EC2 instance. So choosing how much memory we need for it, how much CPU. And part of what we need to do that is profile our application. So establishing a benchmark, a baseline performance envelope for our application, for our workload, so that we understand it and we can then compare it against other EC2 instance types in the future. So building and using a benchmark, enabling automated profiling, and as new instance types are announced, having the ability to test and make decisions based on that information. That will allow us then to continually update our EC2 instance choices based on how performant an application is on the EC2 instance, or how economical it might be. Another option for that deals with choosing the EC2 instance type is actually sort of punting on it and going serverless. And perhaps some of you have heard of AWS Lambda, which allows you to build out entirely serverless architectures using nothing but Lambda itself. There's some really neat use cases using Lambda that you can build architectures from. There's also the use of S3, which allows you to build completely serverless applications using S3. You can build completely static websites using S3. I was hearing a use case the other day of someone who took a WordPress website, a simple WordPress website that they wanted to make super scalable and highly available, but because of the way they were using it, they really didn't want to build out the entire infrastructure. It turned out that instead of building out, using ELBs and multiple EC2 instances and RDS instances on the back end, instead they simply scraped the website daily and pushed all that information up to S3 and served it out of S3 and leveraged S3's inherent availability and scalability. So once you've thought about all of that, and it does require some level of work to perform all that, you have to think about when does it actually matter? When should you be thinking about choosing the right EC2 instance? When should you be making this decision and putting the effort into profiling your application, figuring out what type of EC2 instance characteristics you need? Probably not on day one. Day one, you should probably be focused more on your application itself and the general architecture, making sure that your application is scalable, that it's stateless where possible, that you're using some of the AWS services and features that make applications highly available and scalable. Doing that will allow you some flexibility in choosing an EC2 instance type. Later on, as your workload settles and becomes more predictable, it's generally easier to select an EC2 instance type, to select the size of EC2 instance, maybe a year down the road or whenever it happens to be at some point in the future, but probably not on day one. Maybe year one, you'll probably start to think about reserved instances, et cetera, that sort of thing. But for the time being, it's probably best you can choose an EC2 instance type using that dartboard approach. Try to narrow it in a little bit, but dialing it in on day one is probably not the best use of your time. So that's sort of question one. We do have one question there's a question about CPU performance percent that triggers an instance type upgrade. I think that's the question. So I'll try to answer it. I'm not sure if I have the question correct here. You can do that, but it depends. So I think the question is really, at what point do you decide to choose a larger instance type, for example, or upgrade your instance type? And it can be CPU percentage. That's definitely one of the factors that goes into choosing a particular instance type. But you also need to look at other things like memory consumption. But definitely, if CPU utilization is going through the roof, you're noticing that your application is consuming more CPU, then that's the time to think about a different EC2 instance type. In a scalable environment, that's going to be handled partially by auto scaling. So you can alleviate some of that pain by scaling out, but you also may you may want to think about increasing the size at that point. Another question that came across was, does paying a premium for dedicated instances guarantee better performance? Well, dedicated instances on AWS, it gives you exactly that, dedicated instances. And so you don't have to worry about the noisy neighbor problem. So in that respect, yes, you don't necessarily get better performance, but you're not going to have to deal with noisy neighbors on the same box. It is a shared environment, so as you're selecting EC2 instances on AWS and you're beginning to run and you're running them, they're running in an environment with other AWS customers, and potentially on the same piece of hardware there may be multiple other customers running. It's a virtualized environment. And so yes, if you go dedicated, then you don't have to worry about those other customers running on that same piece of hardware. So you'll get all of the system resources to yourself. All right, so let's go ahead and move on to the second question. So great questions. We'll try to save some time at the end to answer some more as well. But let's go on to the second topic for this morning, and that's building AMIs for your application. So in AWS, we build Amazon machine images for our applications, and we deploy those images to EC2, and that's what actually runs and executes on this virtualized hardware. How you build those AMIs depends, and again, like everything else, there are questions that you need to ask yourself before deciding on which route you want to take. And one thing to be mindful of is in a particular workload, you may have multiple applications that have different requirements, and so your methods and mechanisms for building AMIs may differ. You may come up with a common, consistent approach across all of them as well. So when you're thinking about how to build AMIs for your application, you need to think about what tools you're currently using. Maybe you have a current tool set that you're familiar with, a CI/CD pipeline that you're using right now that has support for building AMIs that you can very easily plug into. That will provide input into what type or what build process you use for building AMIs. Another question is that will dictate what method you use and how often you make updates to your source code. So are you deploying and updating your code on a daily basis, multiple times a day, maybe once a month or once a quarter, once a year? The frequency that you make updates to your infrastructure will help you decide on what methodology you use for building AMIs. Another question that you want to ask yourself when deciding is, how quickly do you need to scale? So when you're, say for example, you have a web application that's running behind an elastic load balancer, and your demand on that web application fluctuates very greatly and sometimes very quickly, then that can help you determine what type of AMI you need to put in place such that it can boot up and bootstrap itself very quickly. Another question is, what type of artifacts or what do you want to maintain? Certain types of AMI generation will require you to maintain simply source code or configuration information. Others will require you to manage binaries in the form of AMIs, and that can become difficult when you're doing it at scale. The answer here is it depends, and there's not one sort of holy grail solution. So let's talk a little bit about AMIs themselves and what makes up an AMI. An Amazon machine image we like to think of as being composed of 4 different parts: the foundation, dependencies, application, and configuration. And I'll talk about each one of these a little bit. The foundation components are like the common base for all of your AMIs. It includes things that everybody needs. Things like the operating system, agents that you like to install on all of your EC2 instances that you're running, monitoring components, logging components, and these could be similar regardless of whether you're running Linux or Windows. You may have very similar components running on all of those. These are the foundational components that you like to have on all of them. The second group are application dependencies. So those dependencies that are specific to your application, that your application requires to run, so additional services that you need to have running on an instance, additional libraries, applications, frameworks. So if you're running PHP, maybe it's Laravel, you need to have that on the instance. And then the third component is your application itself. So that includes things like your application source code, scripts, binaries, libraries, anything associated with your application. The fourth component is configuration. So once you have your foundation, dependencies, and application on that image, what else do you need? You need to know where the database endpoints are, what credentials you need to log into the database, what environment you're running in, whether it's test or dev or production. Maybe you have external services that you interface with, so you need to provide the URLs for those. all of these are included in configuration as well. In addition to these, there are also there's tooling associated with building these. Some people use tools like Packer. Netflix uses Aminator. You can also be using some CI/CD tools in this environment. All of these help you help make up AMI anatomy. So let's talk a little bit about the different types of methodologies for building AMIs themselves. So when we think about building AMIs, we sort of think about them in this way, in two different dimensions. How flexible is the build process, and how simple is it? And sort of going from left to right in these pictures up here, we have sort of these tools in our toolbox that we can use. On the left-hand side are tools that you might be able to use for more than one purpose, or for different sized projects or different sized jobs. On the right-hand side, you end up with tools that are more specific, that are designed for a very specific purpose and aren't necessarily multi-use tools. In the case of building AMIs, we look at them very similar. So the simplest AMI that you might want to make is a really basic one, or in some cases this is called a just-in-time AMI. So you create an AMI for your EC2 instance, and all that is on that AMI is your foundation components. So operating system, agents, monitoring, logging components, and that's it. So imagine a scenario where you're running, again, your website behind a load balancer. It's in an auto-scaling group. It needs to scale up, and so it starts a new EC2 instance. It uses this AMI. This AMI only has the operating system on it and those foundation components. So at boot time, to bootstrap itself, it needs to go out and download and install all of the dependencies. It needs to go to your source repository, pull down your application source code, script, binaries, libraries, and then it needs to go to wherever you store your configuration and pull that configuration down. This type of AMI is super flexible because all of this, in many cases, is driven by script or some other configuration, so it's very easy to make changes. However, as you can imagine, in a very dynamic environment like a web front end where you might need to scale very quickly, this might not be the best possible choice because it could take a long time for this EC2 instance to bootstrap itself and actually get to a point where it can start taking requests from your customers, whether they be people on a mobile device or another service making an API call. This is super flexible, but it's fairly complex. On the other end of the spectrum, we have the baked AMI, which, quite the opposite from the basic AMI, includes essentially everything in it. So you've taken all of your foundational components, your operating system, agents, monitoring, logging, etc., your application dependencies, services, libraries, frameworks, and you've built them into the AMI. You've also taken your application as well as configuration for your application and baked that into the AMI. So it's an all-in-one package. It's very simple. There's nothing that needs to be done to this AMI. If it were in an environment inside of an auto-scaling group and a new instance was brought up using this AMI, it could potentially be very quick to get this instance up to a point where it could start taking customer traffic. So in that sense, it's probably one of the better choices for that type of environment. It can come up and be working very, very quickly as opposed to the basic environment. What we often see, though, is sort of a hybrid approach to this, and this is very common, and it looks something like this, where you've taken your AMI and you've built it using the foundation components and the dependencies. So operating system, application, services, your agents, monitoring, all of those are baked into the AMI. And then at boot time, when it bootstraps itself, it actually goes out your source repository, pulls down the latest source code and configuration. So you get a sort of middle of the road approach. It's fairly flexible in that you can make updates to your application fairly easily. It doesn't require you to build and deploy a new AMI to update your application, whereas in the baked scenario, if you wanted to update your application, you would have to create a brand new AMI for it and redeploy that. In the hybrid model, you can actually do that using the same AMI. You can use your CI/CD tools, you can use AWS code deploy to move new code out, and it will also then, you can also download configuration. So all of these are valid models depending on the type of application you have, what your requirements are for flexibility and simplicity, what tools you currently have in place, what amount of time you want to spend on building out this process. So that's the sort of the summary of AMIs and making that choice. We tend to find a lot of customers who use this hybrid approach because it's fairly simple to build, doesn't require a whole lot of new AMIs to be made, and falls in very well with current processes and methodologies that customers are using. So if there are, looking to see if we have any questions for this section. Looks like there's a follow-up question to the dedicated question earlier. Yeah, so the question is, as a follow-up, yes, so you're in a dedicated environment, you have that physical piece of hardware that's dedicated, but yes, you're still in a rack, you're sharing network infrastructure, etc. So in that sense, yes, you're still in definitely a shared environment. It's not a dedicated rack, no. So the question in this area was, how are AMIs kept updated in regards to dependencies and software updates for things like OpenSSL or other tools? And that has to be part of your process. So depending on which model you choose here, then you may or may not have to make updates to your environment. So in the hybrid or baked approach, if there are changes that are made to your dependencies or other software, you'll have to create a new AMI based on that. And you can use tools to help with that process. So what you really need to think about is how often are these changes being made. If changes are being made fairly frequently, then you definitely want to have some automation in place to manage this, especially in the case of the completely baked AMI, but sometimes in the case of hybrid AMIs as well. If changes are being made to the foundational components or to application dependencies fairly frequently, you want to have some automation in place. If it's happening somewhat infrequently, which can often be the case, and that's really sort of the benefit of the hybrid approach, is you've taken all of the components that change infrequently and baked them into the AMI. The components that change somewhat frequently, like your application and potentially configuration, you bootstrap those dynamically. So yes, if you do have changes to dependencies or foundational components, you'll have to create a new AMI. And best possible case, if you've got some automation in place, you're using a tool like Packer, you're using Jenkins or Hudson or some other tool to automate this process, that's even better yet. All right, so let's move ahead to the next question. Another common question and so just sort of stepping back, these are questions that we help our customers with. So when we're talking with them, when we're talking with our customers who are moving to AWS or building out new workloads on AWS, this is part of the role I play as a solutions architect in this space, is helping customers decide what's the best build process, what's the best AMI build process for me? And we go through some of these questions and answers and figure out what the best possible course of action is. One of the other questions that we get fairly frequently when talking with customers is, what metrics should I be monitoring? What metrics are important for my application? And maybe you're getting tired of me saying this, but it really does depend. That's a very common answer. And so we have different questions that might provide some insight into what types of metrics are important for you. You might ask yourself questions like, well, what do you do today? How do you know there's a problem today? In the absence of metrics and monitoring, what are you doing? What's a good indicator that you have a problem in your system? You know, are you getting increased calls to your call center, a reduction in orders? Those are types of things that you want to look at. And then when you identify those, what are some of the tasks that you actually perform when your application has issues? So what types of things do you need to do? What are some of the biggest challenges with your application today? So do you have pain points? Are there troublesome areas right now that are causing issues? Those are potential areas where you want to put some extra effort into metrics. Another question to ask is, well, what type of metrics could you monitor that are indicative of your customers' happiness or satisfaction with your product? Not just your external customers, but maybe internal as well. So your developers who are working on this, what type of metrics do they want to see? What type of metrics does your business want to see that would provide insight into the application? Let's talk a little bit about some of the answers there. And again, these vary based on the application, but you'll get sort of the gist of it. So let's talk about what type of metrics should you monitor. I mean, there are probably a lot of metrics. A lot of metrics are provided by AWS by default, including things like memory, disk, CPU utilization, instance health, for example. Those are the basics that probably everybody should be monitoring. In and of themselves, they might not be indicative of the health of your application, but at some point in the future, they'll be used probably to correlate some other higher level issue with a root cause. And so for the most part, we always want to have these available, and fortunately for us, AWS provides these for provides something similar along the same lines to these basic metrics for just about every service. So looking at EC2, looking at RDS, just about everything has a basic set of metrics that you can then use. Thinking at a little higher level though, thinking about your customers, what types of metrics could you monitor that are indicative of your customers' happiness? Well, one metric might be latency. So how long is it taking you to service requests? How responsive is your system to customer requests? So, and you can look at metrics like the ELBs, elastic load balancers, provide latency metrics that can provide you some insight into this. Another customer metrics that would be useful would be the availability of your system, so providing metrics that give insight into that, as well as the security of your system. So what kind of metrics can you think of that would tell you if there were any security problems in your system? Other metrics that you might consider thinking about your developers are metrics around dependencies. So your application might make calls out to external services, including calls out to AWS. For example, you're doing some work with DynamoDB and you're using the AWS SDKs to make those calls. You want to potentially wrap all those and collect metrics around latencies for those calls, as well as success and failure rates. Another interesting metric might be database consistency. You have an RDS instance up and you're running read replicas. You want to monitor the lag time between those. Also to monitor the lag time between your database and your caches to indicate whether your TCLs are being effective or not. Also looking at caches in general, cache rates, cache hit, and cache miss rates. These can help developers validate assumptions they made about how useful particular data is or how often data is accessed. Another interesting metric is connections to external services, whether that be databases or other services outside of your application or your environment. So keeping track of the stability and the number of those types of connections can be very useful. Another thing, thinking about it at even a higher level, looking at business level metrics that might be useful for you to capture In an e-commerce site, probably the number of orders taken, number of orders canceled. If you're looking at web analytics, of course, clicks, click-throughs, all of those are valid metrics that you might want to capture. Looking at growth of particular areas in your website or capacity, all of those can be interesting and useful metrics to capture and publish. The thing about metrics, though, is once you've identified them, you have to do something with them. And it's not always just about picking the right metric, but figuring out what your plan is and how you should use them once you have them. So as we talked about in the previous couple of slides, identifying the key indicators for your application is the first step. Finding those metrics that represent the state of your system that you can look at a glance and say, yes, my system is running and it's running well, or no, my system is running poorly and we need to do something about it. So you've identified those key indicators. The next thing you want to do is actually publish those. So get them off of the system. We like to treat all of our resources, or as many as we can, in an AWS environment as stateless, and that means that data is somewhat ephemeral in that sense. And so we always want to get that data off of our EC2 instances or any other services that we have running. So we want to publish them. By default, we publish them. We might publish them to CloudWatch and use the CloudWatch console to monitor metrics, or you may already be using other external metric aggregation services like Datadog or New Relic. The point is, if you're not publishing them and you're not capturing them somewhere, then you can't use them. You can't use them now and you can't use them later. Once you've actually published those and pushed them out to an aggregation point, then set up alerting on those. It's one thing to actually capture them, but now we need to start thinking about what are we going to do about them. So let's baseline our metrics, determine what the upper and lower bounds for metrics are, and start setting up alarms based on those. If they're indicative of problems in the system, that will then trigger that it'll produce some operational pain, and that will turn around and produce input and improvements to the system. When you do that, though, you have to start thinking about what needs to be done. So an alarm goes off, we need to create a run book and determine what happens next. So you get paged at 2 a.m. in the morning because an alarm went off. What are you supposed to do with it? So we create run books around that to establish a process, figure out what escalation paths are. Another thing you want to do with this information is build dashboards. So I think one of the greatest things in the world is to walk into an environment and see a big, huge monitor with key indicators and metrics visible for everyone to see, so that you can actually visualize the health and performance of your application and your workload in AWS. One thing to keep in mind as you're doing all of this, talking about metrics, we should think about instrumenting our code. And by that I mean, and I mentioned it previously, when you're making calls out to external services, whether it be AWS services or your own internal services, instrument them. Keep track of latencies and throughput, success and failure rates, and publish those metrics as custom CloudWatch metrics, for example. Instrument everything you can. Not too long ago, I worked at AWS on the simple notification service team, and it wasn't uncommon for us there, as we were building out new functionality, for every one line of business logic code to have 2 lines of instrumentation code. And believe me, when our pagers went off at 2 o'clock or 3 o'clock in the morning and we went to triage issues and establish root cause, having all of that extra information available was invaluable. The last thing we want to talk about in monitoring is logging. Log everything. So push all of your logs from your EC2 instances out to a log aggregation point, whether that's CloudWatch logs or you're using some other service. Loggly is an example of that. Treat these logs as event streams. There is a huge amount of information available in there that you can actually extract data points from and create metrics from, and use those as another input for your monitoring services. Treat your logs as ephemeral as well. So again, in a stateless environment, if what typically happens is you'll have an EC2 instance that's having an issue, that's having a problem, and you want to go in and maybe you want to SSH into it and look at the logs, but by the time you finally get around to doing that, it was part of an auto-scaling group and it was eventually removed, and so those logs are now gone. So treat logs as ephemeral, get them off as quickly as you can, and you'll have them available for forensic analysis later on. Okay, so that's what we have about monitoring. Again, this is part of what we do as a solutions architect at Rackspace. I work with customers, help them figure out what's important to them to monitor. Also talk a little bit about getting this information off of EC2 instances and into CloudWatch services. So I don't see any questions, so we're going to go ahead and skip ahead to the next question, which is around availability. This is kind of an interesting question, and I'll spend a few minutes talking about it. Again, the answer is really, it depends. And a lot of this comes back to you. And the first part of it is, what does it mean to be highly available to you? As an application developer, your interpretation or definition of highly available may be different from the next person. So while it may be perfectly acceptable for you to have 3 nines of availability and small outages are okay, for someone else that may not be acceptable, and 5 nines of availability is what they require. A lot of it comes down to the type of application that you're running and the business criticality of that application. So does it actually need to be up and processing all the time? Is it something that's customer facing? Is it mission critical or business critical? That can help you determine what level of availability your application should be. And it's important to make the distinction between highly available and between HA and DR, or disaster recovery. We want to think about availability as providing some form of continuity through redundancy or fault-tolerant components. So building out, using the infrastructure provided by AWS to make sure that issues won't bring your system down. And in DR, in disaster recovery, we're really thinking about, okay, in case there was a large-scale disaster that, in the case of AWS, took a region out, for example, how would we rebuild this and get it back up and running in another region? One of the things to think about when you're talking about being highly available is, what's your tolerance for operational pain? So different levels of availability, you may experience different levels of operational pain. So you're less highly available, more operational effort may be required. More highly available, less operational effort. So let's talk a little bit about keys to just general high availability in the AWS environment. And the point to make is, some risk is sort of subjective, where you may or may not feel that certain things are as risky as someone else. And I like to bring this example up because it reminds me of in rock climbing, we think of things in terms of subjective and objective risks. Objective ones are those types of risks that are unpredictable, but we can prepare for. And so thinking about AWS in those terms, there are things like availability zone failures, or EBS volume failures, or instance failures that are unpredictable. We don't know when they might happen, but we should be prepared for them, and we've been given and provided a set of tools that allow us to do that very well. And so I want to talk a little bit about those in terms of keys to high availability. Building in redundancy into your system is probably the very first thing that you need to think about. And redundancy in not just for databases, but for all components in the stack. So looking at our application level components or web level components, using auto scaling groups, using elastic load balancers, choosing AWS services that already have multi-AZ support and redundancy built in. By default, when I'm working with a Rackspace customer and we're talking about building out an architecture, if there's an AWS service that will satisfy their need, I'll recommend using that above building one out yourself and managing it yourself. So if you can use an RDS instance or a managed MySQL database with built-in multi-AZ support, I would recommend using that over building out your own database infrastructure on EC2 instances. Take advantage of the redundancy built in. Also use architectural best practices, so using queues, using SQS or SNS for pub/sub type environments, using queues to buffer and prevent downstream issues when upstream failures occur. The next point is, and keys to high availability are to identify single points of failure in your system and mitigate them if possible. There are cases where single points of failure are going to exist in your system, and we may not be able to completely remove that single point of failure. A good example is a commercial off-the-shelf piece of software that you have. Maybe it's a legacy piece of software that you don't have source code for and you can't make any modifications to, and it isn't inherently scalable or stateless. And in that case, you're required to maintain really just a singleton instance. So we can't put it really in a typical auto scaling group, but we can come up with strategies and plans for recovering that instance, making it as highly available as possible, such that we reduce the amount of downtime and reduce the effect of downtime in that instance, using things like an auto scaling group with minimum and maximum count set to 1, or using the auto recovery feature available in EC2. Another key to high availability is externalizing state. So ideally, we want to make everything as stateless as possible, move everything off of EC2 instances that we can. We want to start treating our instances, if you're familiar with the pets versus cattle quote, we want to treat everything like cattle. In a highly available system, we also want to be monitoring performance and health, like we talked about in previous slides, making sure that we understand what's going on in our system so that we have indicators of potential problems before they actually occur. The other thing that we want to do is make sure that we are failing gracefully. Failures are going to happen. It's not just AWS, but everywhere. AWS, we understand that failures can happen, and we need to be prepared for it. So if a database goes down, can we gracefully degrade to read-only mode? What types of operations can we perform in a degraded mode, that sort of thing, as opposed to simply failing and tipping over. In a highly available environment, everything is automated. So everything we can, we automate. We try to get people out of the process. Anytime hands touch keyboards, there's a potential for issues to arise there. So automating everything we can. And then finally, testing everything, making sure that we have automated testing in place to validate our infrastructure and our architecture and the availability and scalability of our system. Think about tools like Netflix, that Netflix does, like their Chaos Monkey and Simian Monkey. Those are great tools to help you identify issues in your system. So that was a real quick blurb about high availability. This is something that I could talk about probably for hours on end, but just wanted to give a brief introduction to that and answer to this question about high availability. And this is, as I go in and I work with customers and we're looking at architectures, we go sort of through this process of identifying individual components, determining what level of availability that component requires, whether it's an admin box that's used infrequently as a back office type of piece of infrastructure versus a customer-facing piece of infrastructure, what level of availability is required, and then what possible solutions are there for that level of availability for this customer. So those are some of the things that we do on a daily basis. So let's, if I don't see any questions for around high availability, so I'm going to go ahead and go right into our last topic, and I'll cover this fairly quickly. So this goes back to when we were talking about building AMIs. There's the fourth component of an AMI is configuration, and in an ideal world, we keep that configuration off of the instance. We consider it a form of state, and so we want to keep it off of the instance. And so the question comes up, well, how do I dynamically configure my app? What are my options there, and what choices do I have? So going back to the AMI creation, in an ideal, highly available, scalable environment, all state, including this configuration, is stored off of the instance. That includes things like database endpoints, credentials, your environment type, production stage, external service endpoint. Ideally, we don't want to store those on the instance itself, and there are a couple of reasons for that. Number one, it makes that instance not very flexible. So if, say, for example, I wanted to create an AMI that was for my dev environment and I baked in all the configuration, I'd have to have another AMI for my production environment. So now we're managing more and more AMIs, and that can be very difficult to do at scale. So the other issue with that is, you're potentially storing credentials on an EC2 instance, and there's some security implications for that. So in the ideal world, we don't store this information on the instance. When the instance starts, when it boots up or it bootstraps, one of the first things it does is it goes out and maybe it goes to an S3 bucket, for example, and grabs its configuration. That's a very common use case. You create an S3 bucket, you store your configuration information in that S3 bucket. You create an IAM role in AWS, and that IAM role has permissions to read from that bucket, and then EC2 instances that need to read configuration from that bucket are associated with that IAM role. So we're not storing AWS credentials on the instance, we're using an IAM role to do that. Then you also then configure the bucket policy to restrict access to just that IAM role. And when that EC2 instance launches, you can use user data and shell scripts or cloud init to grab that information off of S3, pull it down. You can also enable server-side encryption in S3 to securely store that information, so that even if someone did get access to that S3 bucket, they couldn't read those files. You can also use client-side encryption and KMS to manage keys, so providing a secure level of access to that information. You can also use other tools on AWS like DynamoDB to store this configuration, but in general we want to move it off of the instance itself and pull it down dynamically. So that's really it. Again, there's more details here. I'd like to share with you as sort of a closing slide that it takes some work to get to this state, to get your application to this state. And there are a couple of resources that I'd like to point everybody to. Number one is the 12-factor app. If you haven't seen it, go ahead and take a look at it. It covers some of the material that I've talked about today. The reactive manifesto as well. A very valuable resource for everybody is the AWS well-architected framework, and I've provided links here for access to it, as well as AWS AMI design. That's it for me today. I hope I've answered some questions. I appreciate everybody's time and you sitting through this talk, and I hope you've learned something. I really do appreciate and want to thank everybody. Thank you all.